What is it called? They're terrible except they have one guard that like plays on varsity. He's chef, right? He sits the bench. Right. Our kid's a plumber. What did you talk about? He didn't
Mr. Yang, I'm not going to be here tomorrow, but it's just the classwork.
Yeah, nothing new tomorrow.
All right, okay, cool. And then you're going to put like the answers to everything on your website.
I did not read this.
How many of you have last game?
I'm working now.
Don't work.
I'm gonna watch it Friday. I'm not.
I was still
That was like
See, this is.
It makes it worse. It makes it worse.
I don't run places.
I follow them on Instagram. And they make.
I received like what you call it, that works. That's like
Okay, if you guys can turn to page 12. Again, we're still just circling around this component form, Pythagorean theorem, trig. So really nothing new, but we're just kind of getting more used to vector notations. So page 12. We're going to cover two sections today, but both sections are short. We'll start some of the classwork, and then you'll finish the classwork tomorrow. Okay. So if you guys copy this down first, component form is basically the horizontal and the vertical components of a triangle, right? We talked about how anytime we create a vector, we can always force that vector into a hypotenuse for a right triangle, and then the legs of that triangle represents the horizontal and the vertical component. So, example, we're going to draw the following vectors. A vector with horizontal component 2 and a vertical component of 4. We can just treat like every value as starting from the origin if we wanted to. So that means a vector that has a horizontal and vertical component of 2 and 4 means it's going to be going 2 units to the right and 4 units up. Okay, any questions with the first example? Okay, second vector, horizontal component of -3, vertical component of 1. Okay, so 3 units to the left, 1 unit up. Okay. Guys. Next one, vector with horizontal and vertical component, both negatives. Yep, third quadrant. And then 2, -10, fourth quadrant. Yeah. Okay, so if we just had something in component form, we just have to count. But if they give you ordered pairs, you would have to build the component form using this formula rather than having to just graph everything out. So here is how we can build component form given ordered pairs. So if I want to find a vector in component form A, B, And if I'll have order pairs to work with, I'm just going to spend the time to subtract my x and y values. Now, direction is important because it tells us that if we're starting at C and we're ending at D, that means C is going to be your x1, y1, and D is going to be your x2, y2. Okay, so you always want to look at the arrow where it's headed. So wherever the arrow is headed indicates where you're starting and where you're ending. So in this case, we're going from C to D. So C is going to be your x1, y1, and D is going to be your x2, y2. We're starting at order pair of 7, -3, and we're ending at 9, 1. So that's going to be important because we need to make sure that we're able to create a vector that's pointing in the correct direction. Right? Okay, so in this case, our vector would be x2 minus x1, so 9 minus 7. And y2 minus y1 will be 1 minus and -3. Keep track of the two negatives here. So therefore, vector CD would have a component form of reduce these values, so 2 and 4. If we were to draw if we were to connect the 2 points and draw a triangle, that triangle will have a horizontal component of 2 and a vertical component of 4. Okay, next up, operations with vectors. Just like how you would expect, you would just add like terms together. So if I want to add vectors u and v together, I would add the x components together and add the y components together. So if I want to add vectors u and v, I would just add a1 and a2 together. And then for the y component, I would add b1 and b2 together. If I want to do vector u minus vector v, then I would subtract each of the x components and each of the y components. A1 minus A2, and then B1 minus B2. K is just a scalar, so a coefficient. So if I have a constant in front of a vector, I'm just going to distribute that constant through the vector. So if I distribute that K through vector U, it'll just be K A sub 1. Sorry, and then K B sub 2. Okay, so here should feel pretty straightforward. We're really just going to be adding our vectors together. So x component goes with x, y goes with y. So okay, so vector u plus vector v. Add the x components together and add the y components together. Okay, vector u minus vector v. Okay, so subtract the x components and then subtract the y components. All right, 2u minus vector v. So if I distribute 2 through vector u, I would get negative 8, 2. So I want to take that vector and I want to subtract vector 2, 5. negative 3u minus 4v. So I want to distribute, multiply vector u through with negative 3. For v. Okay, so there's my negative 3u and there's my 4v, right? Combine those together. Twelve minus 8 is 4. Negative 3 minus 20, negative 23. Okay, unit vectors. Definition for unit vector is a vector with magnitude 1. Okay, I is representative of a unit vector that is on the positive x-axis. So vector I, or unit vector I would represent 1, 0. Okay, J is unit vector on the positive y-axis. Okay, linear combinations of unit vectors. Sometimes it's easier to use I and J for certain problems. So sometimes if I have vector AB, I can also represent this as, if I want to put it into unit vectors, I can say this as AI plus, okay, B times J. So that just allows us to get it out of component form into something that we can add and subtract. Okay, so vector, write vector negative 3, 8 as a sum of unit vectors. So we simply just let the negative 3 go with I and let the 8 go with J. Okay, write vector 0, negative 5 as a linear combination of unit vectors. What would that be? Yeah, 0i minus 5j, which is just really just what? Just negative, yeah. We don't have to include that 0 since it just goes away. Okay, find the vector with initial point x and terminal point y as a sum of unit vectors. So anytime we have order pair, we know we're starting at x, we're ending at y. So we know this is x1, y1, this is x2, y2. So we're going to build our vector using this formula above, right? x2 minus x1 is the component form, and then y2 minus y1 is the vertical component form. So we'll put in component form first, and then we'll transform it to unit vectors. So vector xy can be written as component form -7, 1, or as -7i plus 1j. Appreciate it. Good, thanks. Okay, let's go to the next page. And we're just going to do, if you look on the board there, tomorrow we're going to try to finish the rest of 1 through 35, but we're just going to do one of each so they can kind of use those to as models for other problems. So any questions, page 12? Okay, so go to page 13. Okay, we're just going to be looking at the odds here. So tomorrow, I'm going to ask you guys to finish 1 through 35 odds, but today we'll just do 2 of each so that you can kind of see how the problems work, and then you can finish the odds tomorrow. Okay. All right, so this is right component form with initial and terminal points. So A is initial and B is terminal. So this is the x2 minus x1, and then the y2 minus y1. It's 5 minus 1. Okay, number 3, same thing. x2 minus x1, and then y2 minus y1. Okay, any questions there? All right, let's skip down to 11 and 13. Find each of the following. For h minus g, we're just pairing, matching up component form x with x, y with y. For h would be minus g. -24 plus 3 will be -21. 8 plus 5 will be 13. Okay, 13. 3g minus 5f plus h. Okay, add all the x's together, so -9 minus 40 minus 6. Okay. Merge all the y components together, -15 plus 2, -13. All right, let's skip down to 29 and 31. So let's get this in terms of, I like to go through component form first and then transform it to unit vectors. So initial point D, terminal point E. Okay, any questions here?